Welcome back everyone to 3 Inquisitive Kids. This video will be about mixed operations with rational numbers. Lesson 11, combine the 4 basic operations together to calculate. Here's a course outline for Chapter 7. You can see that we're already on our second to last lesson of this unit. So congratulations for making it this far. Today we'll be learning about mixed operations with rational numbers. Learning goals. Master the 4 basic operations of arithmetic. We're also going to be using some exponents. And learn how to simplify expressions using the order of operations. We actually made an order of operations video earlier on, and I will give you the link to that in the description below. What operations have we learned so far? So we've learned addition, subtraction, multiplication, division, and exponents. All of this is based off of addition. Subtraction is the opposite of addition. Multiplication is the form of repeated addition, and division is repeated subtraction, or you can say the opposite of multiplication, and exponents is essentially just repeated multiplication. Randomly draw 4 cards from a deck of playing cards without the jokers, and perform mixed calculations based on the numbers on the cards. Each card can only be used once, so that the result of the calculation is 24 or negative 24. The red playing cards represent negative numbers, and the black playing cards represent positive numbers. And J, Q, and K each represent 11, 12, and 13 respectively. You can see here that we have 3, 4, 5, 9, 5, A5, 10K, AK. If you have a deck of playing cards nearby, you can quickly take them and randomly select 4 cards to do some math. Here are some basic calculations with rational numbers. I want you to calculate these 2 expressions. The first one is negative 2 plus 5 minus 8, which equals 3 minus 8, which equals negative 5. And for the second problem, we have negative 100 divided by 25 times negative 4. That's the same thing as negative 4 times negative 4, which gives us positive 16. You can see that here we have addition and subtraction and division and multiplication. So all we had to do was calculate from left to right, so we would be in the right order. Here are some more calculations with rational numbers at a slightly higher level. Example 2, compute. 14 minus 14 divided by negative 2 plus 7 times negative 3. We have 14 as our first term, and since we have division here, that's considered one single term, so we first simplified that, and we're left with minus negative 7 plus negative 21, because 7 times negative 3 is negative 21. And when you combine these terms, you get 0. Based off of the order of operations, first simplify the multiplication and division, and then do the addition and subtraction. You can see here that we basically just put some parentheses around the division and multiplication, because every single term is only separated by subtraction or addition. When you have 2 numbers that's being multiplied together or divided together, they're actually part of the same term. Now try adding on brackets and parentheses. Compute this expression. You can see that this is more of a level 3 calculation. We simplified this 1.6 times 5 over 8 into 1, because we first do multiplication and division. And then in the second step, we simplified this very inner parentheses into 0. So it's negative 4 plus 0. And this negative 4 comes down here. And now we don't really need this curved brackets anymore. So we bring this divided by negative 2 down here. And negative 4 divided by negative 2 equals positive 2. But you can see that there was a negative sign outside these brackets, so it's minus positive 2. And then we still have to do the division, which is negative 2 divided by 2, which equals negative 1. So negative 3 minus 1 equals negative 4. So that might have been a lot for you, and I want you to pause the video and go over the solution by yourself one more time. Simplify from the inside to the outside. First, calculate the parentheses, then calculate the brackets, then finally calculate the braces. Here, the braces are these curved brackets. You can see that for the first step of this expression, we started from the very inner parentheses, and then we moved out to the brackets, and then we moved out to calculating the entire polynomial. Now we have the exponent. I want you to pause the video and simplify this expression. Here we have 2 squared, which is an exponent. 50 divided by 2 squared times -1/5 is one entire term by itself. And that's the multiplication and division. In here, we've highlighted out the 3 separate terms that's in this trinomial or polynomial. 3 is a term itself. This bracketed part in the middle is actually one term, and -1 is a term by itself. What kinds of operations does the formula above contain? What is first, and then what do you calculate? So what's the order of calculating? First, we have to do the exponents. And then we can do multiplication and division. And then we can combine all the remaining terms with addition and subtraction. Here is the order of operations for calculating rational numbers. First comes exponents. And then you do the multiplication and division. And then you finally add them together using addition and subtraction. And if there's any parentheses, this is actually not step 4, this is a note. Perform the operations in the parentheses first and then work your way out. So first parentheses, then exponents, multiplication, division, and then addition and subtraction. Now, after learning all of that, let's do some practice. Example 4, calculate this expression. The answer for this problem is 17. First, we can see that this is actually a binomial, a polynomial with only 2 terms. This is one term and 18 is a term by itself. And we calculate what's inside this parentheses first. You work your way from the left to the right. 6 divided by -2 equals -3. -3 times -1/3 equals a +1. You can see that here we still had a negative sign, so that's why we have to minus +1. 18 minus +1 is 17. We must pay attention to whether the terms we're working with are negative or not. Example 2. Here we have -3 squared times the sum of -2/3 and -5/9. Our solution for this problem is to first do the exponents. -3 squared is +9. And then we simplify the parentheses, or you can say in this case brackets, which gives us -11/9. Then you multiply to get -11. And here's another solution. First, we still have to do the exponents to get +9. And then we can use the distributive property of multiplication to get rid of the parentheses. And we're left with -6 plus -5, which is just -11. Well, which method did you prefer in this case? I want you to think about it, because for different problems, you'll have to use different solutions. We know that the properties of addition are a plus b equals b plus a, which is the commutative property of addition. A plus the sum of b and c equals the sum of a and b plus c. That's the associative property of addition. And the properties of multiplication are the commutative, associative, and the distributive. You can use these properties in reverse too. So sometimes you have to, instead of using the distributive property of multiplication, you have to factor out a number that you see all terms have. Sometimes that will help you. Now I want you to compute this expression. Here we first do the exponents. 15 minus 15 divided by this -1 to the 11th power is the same thing as just -1, minus 25. Because this doesn't have parentheses around it, then this is a -25 instead of a +25, times -1/125. The reason we turn this into fraction form, it's because it's easier to work with fractions, because you might be able to cancel some things out. And then now we do the multiplication and division. -15 divided by -1 is +15. -25 times -1/125 is 1/5. You add them together and we're left with 30 and 1/5. Here's example 2. Our solution for this problem is to first use the distributive property of multiplication. You can see that they distributed this -3/4 into the polynomial. And now, since we've gotten rid of our brackets and parentheses, we can move on to solve the exponents. -3/4 times -8 minus 1/2 minus -1/4. Then you cancel out and we're left with 5 3/4. Now we're going to learn something called the 24-point game. From a deck of playing cards without the jokers, randomly draw 4 cards and perform mixed operations based on the numbers on the cards. Each card can only be used once to make the result 24 or -24. The red playing cards represent negative numbers and the black playing cards represent positive numbers. The jack, the queen, and the king each represent 11, 12, and 13. Again, this is the game we were talking about in the introduction, right? So Kanbin drew out the following cards, and he used this method to make up 24 as a result. If you drew the exact same cards as Kanbin, what is another way for you to make 24? If you want to, you can pause the video and think about this for a moment. One way you can make 24 is 7 times 3 divided by 7 minus -3. You can play around with the operations and the signs yourself. So this is the same thing as 7. We're going to use the distributive property of multiplication. 7 times 3 over 7 plus 7 times 3. And this 7 and this 7 cancel each other out. 7 times 3 equals 21. 21 plus 3 equals 24. That's a smart way to make 24. Question 2. If you drew these cards, can you make 24? So now we've given you 7, 3, and 7, 3. Again, still the same numbers. Here's another way to make this. You can make this -7 times parentheses -3 divided by 7 minus 3. This is technically the same thing as a previous method, except that you played around and you kind of changed the operations and signs. But we're still left with 24. Or you can make it 7 times parentheses 3 plus -3 over -7. Still, it's the same thing. It's just that they switched these two terms around and also changed the signs a bit. There are 4 rational numbers, 3, 4, -6, and 10. Add and subtract, multiply, and divide these 4 numbers. Each number can only be used one time to make the result equal to 24. Write an equation using these numbers to make 24. So if you come up with an answer, you can put your answer in the comments below and we will look at it. Let's share what solutions we have. Today we learned mixed operations with rational numbers. It was basically a review of what we learned in the previous lessons. And we learned about the order of operations and how to simplify your calculation. You can use the distributive property of multiplication, or you could just do the parentheses itself. And we played a little bit of the 24-point game. So this is our second to last lesson of the unit, and our next lesson will just be about some buttons on the calculator and how to use a calculator. But if you're feeling like you can move on, the next step for you is to watch Unit 3, Grade 7 math lessons.